Okay. Um, just out of curiosity, you can be perfectly honest. How many people in here feel like you like know a pretty good chunk of the language now after learning it? Okay, so it's not like just going over your head. Everyone feels like you're actually learning the language. This is I've been teaching this course a few semesters, but this is the first semester that I've had like a full class. Previous semesters, it was people who had already taken like 3 or 4 programming classes, and this was like their 5th programming class. So that was kind of the audience. But a lot of people here, I imagine a lot of you just took your COP2030, and this might be your 2nd course, so that's good. I haven't lost too many people. So let's talk about this right here. Blackboard's the worst. It somehow pinned the midterm rules up here, and I don't know how to change it. But whatever. So as you know, I'm very assignment heavy. I don't like to do the quizzes and all this other stuff and attendance grades and stuff like that. But obviously that means if you miss an assignment, that's kind of a big deal. That drags you pretty much an entire letter grade. In most cases, an entire letter grade. And so what I usually do is at the end of the semester, if you're doing all right, and that you just kind of either messed up really bad on one assignment or something happened. I understand stuff happens. I'll let you do a makeup assignment, most likely for not full credit but partial credit, but it's better than a 0. So either if you did really poorly, like you got like a 50% on the assignment, or you just didn't do the assignment at all, you can have one makeup assignment. And I usually do this offer every semester to a lot of the classes, not all of them, but many of them. And some people try to get like kind of sneaky and be like, well, maybe he won't notice if I do 2 assignments. And so if I notice, and I will notice because I go ahead of time and kind of put everybody's name in the spreadsheet. If you try to do that, if you start trying to just give me all the work for the whole semester, I'm just not going to grade any of it. Okay, so don't try to pull one over and think that you can get around the system. It's just for one single assignment. Okay, so hopefully that'll help people. If you've already got an A or B on the assignment, like your worst grade is a high B, it's probably not worth your time because you're probably still going to get an A in the class anyway. Okay, so anyway, but make sure to have that done by December 2nd, and be very, very strict about that because like if you try to do it on the 4th or something like that, I'm not even going to bother because I want to have these graded like right away because we're hitting the end of the semester. So okay, so that's that. I don't want to get too heavy into announcements. One of the things that we've talked about is we've been doing everything in REPL, and we've actually done pretty good so far. I'm surprised that requests library even worked in REPL. I went to do something the other day. I wanted to talk about message buses and message queues, and there's one called MQTT, which is very popular with IoT stuff. I went to use it, and we hit our limit with REPL. But you know what? This is a good time because we've been relying on REPL probably way more than I had expected at the beginning of the semester. So what we want to do is install our own Python distribution, install it on our own computer, and this is a good thing to know. So let's go ahead and do that. It takes a while. That's why I'm kind of rushing into it. So everyone just Google for, they have all these different distributions. There's the official distribution from python.org for Windows and stuff like that. For Windows, I tend to like to use one called Anaconda. It's geared towards scientific computing, but it has a lot of cool libraries already installed and has a lot of interesting things. So let's go ahead and use that one. So type in Python, Anaconda, maybe Windows download, something like that. Now, typically, if you're on a Linux system or Mac, Anaconda is available for other platforms, but I've never used it for anything but Windows. Most other things, like on Mac, you just do a brew install Python. Most Linux distributions come with a reasonably new version of Python. Now, for anybody who's on a Mac, do be careful, because Mac does come with Python, but what version of Python does it come with? 2, which is very, very old. I'm surprised they still do that, but anyway. So if you want Python 3 on Mac, you do have to... There's brew install. That's what I use is brew. Are there other methods that anybody's tried? I think that's the most straightforward one that most people do. Okay, so click the first thing. So again, we just downloaded Python, Anaconda, Windows download, and we'll just go with the default installer, and we'll go with the 64-bit graphical installer. Now this actually may take some time. That's why I wanted to go right into it. Hopefully it doesn't take a full hour. I'm hoping I'm just for the download, and we can talk about other things for 10 minutes. What's everyone's timers at? Is anybody over 10 minutes?
Is that 4?
Okay. Okay, so while that's downloading, just to let you know, so we have these different Python distributions, and this includes Python, the language, plus a bunch of extra tools. So there's like a package installer called pip. They actually have their own called Conda. I haven't really used it much. Maybe we can try it today to see if it works halfway decent. But then there's the Python standard library, which is important. That has a lot of these different, anytime we use import, most of the time it's been the standard library so far. But then, sometimes there are third-party modules and libraries that we want to install. So we'll go through that a little bit today. And okay, so that's installing. That should be straightforward. We're just essentially installing Python. Sometimes I want to keep simple things simple. And okay, so while that's going, let's go ahead and open up a REPL. Again, we're just kind of doing random things that I think are important at this point. So let's go to resources. So one of the really cool things about Python, and I'm not going to give you an assignment on this because I realize this is going to be kind of a weird thing for most people in here. I think a couple of you that may have already know the language, you might be, oh yeah, everyone's downloading all at once, so it's going to be crazy slow. Let's see if we can get one REPL open. Let's see how that works. So functions are kind of a funny thing because Python is such a dynamic language. Sometimes what I want to do is I want to create a function that accepts another function as an argument. How many people have heard of that before? The technical term is functions as a first-class argument, so a couple people. Why would I care about doing that? Why is that important? One of the most obvious scenarios are things called callbacks. So what I do is I have something going on. Let's say, for example, I'm waiting for a message, and I want that message, I want to wait in the background. It's called non-blocking. There's two methods of a program running. I can have it run and block and wait for something, or I can have it run in the background, non-blocking, and it's sitting, usually spins off in another thread or something else asynchronous. And then what happens is that I have what's graphical user interfaces. This is a perfect example of that, is that there's a lot of code running on a graphical interface, and then I press a button, and then there's a callback. And what you want to do is you want to pass it a function. You want to say, when this happens, when this user clicks a button, I want you to call this function for me. That's why we have these as first-class functions. It's because I want to pass a function to another function. Another example is if I'm doing threading. This is very, very common in threading, is that if I want to start 10 threads, how many people have heard of threads before? You have a general idea of what threads are. Threads are essentially, it's like you're running things in parallel. Like it spins off another, not quite a process, but you could sort of think of it like that. Imagine you have 10 versions of your program running at a time, or you could have 10 threads, and then what you have is a thread manager, and then you say, okay, I want this thread manager to run this one function 10 times. You have to pass it a reference to the function. So we have this idea of functions as first-class citizens. Okay, so mine finished. How many people are still downloading? Should give us just enough time to get through this. So a couple people. It says a day?
Yeah, hers was a day, but now it's down to a minute.
Okay, perfect.
Yeah, as soon as yours sped up.
Okay. Okay, so let's do kind of a weird example here. So I've got a function, and these are gonna be very generic functions. You know how like in algebra you have like f and g, and so let's just make a function called f. It's a super straightforward, simple function. All it's gonna do is it's gonna take in a parameter s, and all it's gonna do is print s. Let's call this function and have it say hello. Actually, let's do two versions of this function. Okay, so the first, because I want to step through this. So the first version, we're actually going to hard code the word hello. So here we're just going to call it f. Because parameters, that's going to be another little talk that I talk about in a little bit. So we'll do simplest function. All it does is print hello. What's it complaining about? Did everyone get this? Let me just retype the full word. Maybe I missed something along the way. And then call it again, so it's just going to be f. There we go. That was weird. Okay, super simple function. Say I had another function called process. And this was some sort of long-running process, but when it was finished, and let's pretend this process ran in the background. And it takes like an hour to run. And so this process function starts up, but then we write some threading code and it runs in the background for an hour, but it keeps the rest of our program from freezing. And at the end, we want to call this f function. And so what I do here is now I just call process. Process does something for a long time. We'll just add a comment that we'll say 1 hour wait time. Just some long thing happens. It does a bunch of number crunching, and at the end, we want it to execute f. Right now, we've hard-coded the function that executes at the end. Make sure I am streaming, right? Okay. We've hard-coded the function that executes at the end. What if I wanted to instead have the option to pass it another function, g? So instead, this one just says done. Now, if I wanted to use g instead, I would have to go inside of the function. Let's think of a real-world scenario. What if I couldn't modify this process function? Somebody distributes something as a third-party library. It's closed source. I don't want to have to go back and some standard library and modify the standard library. I want to leave process alone. I want to have this process function to where I can accept as a parameter which function to execute when it's done. Does that make sense? Bless you. So I don't want to imagine that process is off limits, the internals of process. Somebody else wrote it, and either because of administrative purposes, or even process could be in the standard library, to where you don't want to modify the standard library because that's kind of a big deal. We want to be able to accept the function as a parameter. And we can actually do that. What we can do is we can say, we'll call it funcref. So it's going to be a reference to a function. And then rather than executing f or g, what we can actually do is we can execute func ref. Now, what do you think I passed to line 11? Because obviously now it's taking in a parameter called funcref. And now I have to change when I call the function. Remember, this is our blueprint. When I actually call the function on line 11, what do you think I have to pass in here? Yeah, and so walk me through it exactly, character by character.
So, you put F parentheses,
Yeah, so let's think about it like this. So this is interesting because this actually executes the function. So what'll happen is when we do this, it executes the function and then it gives the result. So it's not going to work like we think it's going to. But what's interesting, remember I told you this idea that functions are first class objects or whatever they call it. I can't remember the terminology they use. But the basic idea is that I can actually, I'm going to comment this out really quickly. Oops. If I just use f by itself, that gives me back a reference to the function, but the function does not execute. So if f or g executes, we should expect to see either hello or done, correct? That's actually what we saw up here. But if I just print f, would you expect the function to execute? No, because we're not actually putting the parentheses. The parentheses makes the function execute. So what this is going to give us back is a reference to the function. So what's cool about this is that now we can take this and we can pass in f, and then it takes that function reference and actually executes it. And then if we decide in our code, remember process is off limits. We cannot touch any of this code right here. And I want to say, okay, at the end of the process, I don't want to execute that first function. Instead, I want to execute this other function. That's really, really, really powerful because then we can have various callbacks. And I can write a generic library that what it does is, like when something finishes, or some process happens, or something happens, give me a function and I'll execute the function for you. But then we run into a little bit of a problem because what happens if f and g take in some parameters? Let's say, for example, they both take in a parameter, something like this. I know this is kind of manufactured and made up, but one says hello and then the string, and the other says done in the string. So we're taking in some parameter. This isn't going to work anymore. We can't do this because what happens when I put parentheses? It executes it. But we can't just do this because that doesn't have enough information. So we can use it as a special operator. I don't know the official name of it. In other languages, they call it the spread operator. I don't think that's what they call it. I tried to look it up earlier. Yeah, this is the operator. Yeah, JavaScript calls it spread. Some call it splat. Unpacking argument list. But the basic idea is that what I can do is I can say, okay, pass in a list of arguments. So if I had 5 arguments, I would pass in 5 different things into this tuple. A tuple is like a list, remember? Works basically the same except for it's immutable. And I want to pass in my argument that says finally. So hello finally or done finally, kind of a silly example. But notice that process doesn't take 2 arguments. So what we have to do here is we have to say, okay, these are going to be the arguments. And then within our function reference, what I have to use is this unpack operator. And this actually spreads it out. So it takes my list, and we'll do one more example that this might make a little bit more sense. Hold on. 8 we're given. I think we have to put a process G. We might have to spread it up here too. Hold on. Oh, that's why. Okay, yeah. Sorry, it needs a comment at the end because otherwise it doesn't see it as a tuple. I think it sees it as a set. It's minor technical detail. Just put a comma at the end. So now we can arbitrarily call any function as an argument for another function and pass parameters as needed. And then we could even, if we wanted to, have another argument here, and then just do something kind of silly, just print t, I guess. Doesn't really matter. We do have to be careful, though, because these function signatures have to match or else this doesn't work. So they both accept s and t. Now, how do you think... do you think we'd have to modify 9, 10, and 11 at all? By adding one more argument, do you think we'd have to modify it? It turns out we actually don't. It's very cool because all of the arguments are packed inside of this args variable as a list, essentially. And then this star operator splits them apart for you. It spreads them out. So now if we want two things, like say, for example, we just said, let's see, 2030. All we have to do is change our functions and our callback, but we never have to touch process. It's very cool, very useful thing. I'm not going to give you an assignment on it, but I think some of you that go into advanced Python, you will see this. You will have to deal with callbacks, okay? But everyone has this executable done now, right? So let's go ahead and run this. It might take a little bit to install. Just accept all the defaults. Just click next, 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 next. Just me. That's fine, okay. This one always takes a little bit, the package cache. So that's installing. This final example, I don't know if it'll actually work or not. We'll see. Okay. Let's talk about real world scenarios. And again, I know some of this stuff seems random, but it's like some stuff. We got through the core material of it. Now it's just like me as a Python programmer, what I've seen over the past number of years, things that you do in the real world. That's why it's a little bit disjointed. It's just random things I've had to do that I want you to, if you see it in the real world, I want you to know how to do it. So we talked about this idea of web servers last time, or web services, a couple classes ago. And if you remember, the basic idea was a company like Twitter or Facebook or something, they make a product. Now, they can't just give me all the data for Twitter and Facebook. So what do? They create what's called an API. And I connect to their servers, and I run some code, and some stuff happens. So, for example, I might, through my code, be able to run a search for all the tweets by a specific person. And then it would return it as, what's the most popular file format for it to return as? We talked about this? JSON, exactly. It's not the only, but it's very popular. So I connect to their server, they send data back. It's called request reply. I request data from them, they reply back. It's a very, very popular way of doing things. This gets into this idea of messaging. It's very, very uncommon for very large programs to be what's called a monolith, just for the whole thing just to all be one giant program. What happens in the real world, if you're working for a large company, in small companies this tends to not happen as much, but I realize, I just want to give you the full picture. Because some of this stuff is actually could be used for smaller companies, but it's underutilized. So this is this idea of messaging patterns. That's request reply. Now, think about a real world system. Think about like a Google, for example. Google probably has 100 software products spread across their whole platform. They've got their email system, they've got their data analytics stuff, they've got their ads system. All these things need to intercommunicate. In software, we want things to be loosely coupled. We don't want them to be tightly dependent on each other. I'll give you the simplest example. Is that in the 1970s, when people started to write accounting software, let's say for banks, what they would often do is they'd write the business logic and the user interface all together. Now in the 90s, when we started to get web pages, what happened? All that business logic is still valid. Just because the web goes online doesn't change fundamentally how a bank operates. But many times they would have to rewrite the software. What did we get in the about 10 years ago? What new piece of technology? Smartphones. We got apps. Are you gonna want to have to rewrite all that software again for apps? No. So what we do is we decouple the user interface and the business logic. This idea of decoupling is that you take things and you try to make them stand on their own. There's actually a whole movement of these things called microservices. I don't really use them often anymore because I don't, obviously work at a large company. But it's this basic idea is that you want things that have one purpose to stand on their own. So say, for example, if you're at a bank, well, let's take our simple example of just, we've got our business logic and our user interface. I should be able to change out user interfaces while having all that business logic stay the exact same, because how a bank operates has nothing to do with whether you're operating on the web or, you know what I mean? Like, we're still dealing with deposits, we're still dealing with withdrawals, we're dealing with interbank communication, we're dealing with overdrafts, all that sort of stuff that a bank deals with. Now, one of the easiest ways, so we've got these two separate systems. We've got a user interface and we've got our business logic. But how do we communicate between them? Well, we could write some code that calls one or the other. We could call functions back and forth. But if we really truly want it to be independent, oftentimes we'll use these things called messaging systems. We'll use something called a message broker. And what it does is that you agree on a standard file format, let's say JSON. JSON's very popular. And all the different user interfaces understand JSON, and the back-end business logic understands JSON. And then what you do is that you communicate through that. Now what would happen is, okay, so let's leave the bank example aside for a second. Let's think about how many people heard of IoT, Internet of Things. It's basically, in the 70s and 80s and 90s, we had industrial systems, things like, like water utilities and FP&L and stuff like that. And they have big systems where they've got big generators and pumps and motors and all this stuff. And they worked in a world for a while. But IoT has taken a lot of that and it's shrunk it down. And it's all internet-based. So all their systems usually are on private networks using protocols like Modbus and RS-485 and stuff. But IoT, they said, let's modernize it and let's put it in the home. So to do that, they use most of the stuff's on the internet or TCP/IP in general. And it's, obviously not big pumps and motors and stuff. It's usually things like thermostats, your front door lock, stuff like that. So that's IoT. So you've got a bunch of devices, and you may not know which devices are in a given home. Let's say, for example, I'm Google, and I'm trying to make like a very complete product that I want to be able to control everything in the home, but I don't know what's in anybody's given home. So what they do is they write these things called a message bus or a message broker, and a very popular pattern is called publish subscribe. And what will happen is it's a very loose coupling. We've got all these different sensors and devices sending out events. They don't care who gets the event, they're just sending out the event. For example, air conditioner turned on, door unlocked. What's another IoT device? Somebody can give me an example.
Nest.
Yeah, so what's something Nest might do? Yeah, change thermostat or light turned on. You get the basic idea. There's some sort of sensor event that happens. Now, what it does is, as a thermostat, I don't care who gets my temperature change event. I just want to be able to send it. So that's publish. Then we have subscribe. Who might be interested in a subscribe event? Well, I might publish it, and maybe there's like a user interface. You might have like a little like monitor or something like that with connected to a Raspberry Pi. And so I publish to whoever wants it, and then at the other end they subscribe. So I might have a monitor with a Raspberry Pi, or I might have a log file, or it might get sent out to like in the extreme case like an FP&L. I know they were working on smart technology for a while that they could kind of monitor in your home. I think they might have scaled it back a little bit, but you get the idea. So this pattern is called publish subscribe. Very, very popular with IoT. Is that you've got a bunch of sensors on the network, let's say a weather station that keeps on sending out what the current temperature is. And then we've got people who subscribe to the event. Now, do you think the publisher doesn't know anything about who subscribes? All it does is says, I'm going to send out this JSON data. Whoever wants it can have it. And so we've got this message broker that sits in the middle that does all that. A very popular one is called MQTT. Okay, so I want to talk about that. But what's cool is with modern microservices, people are using it for all kinds of really interesting things. So say, for example, a big corporate system, you might have your email processing system, you might have your billing system, you might have your trouble ticket system, you might have 5 or 6 different systems. They could be written in different languages. One could be in Java, one could be in C#, one could be in Python, one could be just like some shell scripts or something like that. They all can communicate as long as they use the same data format. A very popular one is JSON, but there's other. Google has a really cool one called protocol buffers, but unfortunately protocol buffers was only available in a few languages, Python, C++, Java. There's other languages, but it's not officially supported by Google. There's one that I like, it's called Message Pack. That's pretty cool. But JSON's kind of like the unifying. It's not the most efficient, it's not the most readable, but everyone seems to speak it, so that's what we use a lot of times, okay? So we're going to revisit that in a second. We're going to revisit message patterns, okay? Does everyone have installation complete? Okay. So let's, we don't need to learn more. Let's go ahead and finish. Okay. So we've installed Anaconda, and if we go to start, we should just be able to type in Anaconda prompt. Now, first thing is that I want to make sure, that I actually have Python installed. So this gives us a special prompt. It's normally with our normal command prompt, like Python's not, pip, which is another tool that none of this is installed. But what's great about this Anaconda shell is that it sets up the environment for you. Okay, so I can do things like just type in Python, and it knows how to find Python. Okay. So if we want to get an interactive Python interpreter, we just type in Python. We can do our normal stuff like 1 + 1, great. And if you want to exit, you hit Control-D. Control-D as in dog. And that'll send an end of file. Now we're going to be lazy. Let's work on the desktop directly, which is probably a bad idea, but so let's CD to desktop. Just makes life a little bit easier. Okay. So one of the libraries that I want to go through today is called MQTT. MQTT is actually very popular because I could implement it in C on a microcontroller really, really easily. There's a whole host of other message protocols, but MQTT is nice because you often see it with IoT because you can implement it in C very, very easily. Okay, so we want MQTT Python. That should be enough. Yeah, so if you do MQTT Python, so it says pip install this thing. We'll get to that in a minute. So this is a Python library that can speak MQTT. And if you scroll down enough, they give you some sample code. Okay, so we'll work on that sample code in a minute. But to use it, we need this MQTT library. And I can tell that I need it because if I were to try to import it, it's going to say, I don't know anything about MQTT. Okay. So most of the time, the most popular package management tool in Python is called pip. And it's got like a central repository. So if we go back to our terminal, make sure you're not inside of Python. Make sure it just says base and then desktop. Let's go ahead and pip install PAHO, which is like a, it's hard to explain. They're like an organization basically, like an Apache or something like that. I think they're actually part of Apache, and then MQTT. So pip install, yeah.
I'm trying to figure out how to point to the desktop correctly. Is it?
It's just, it should just be CD space desktop.
Gives me invalid.
Yeah, ignore Python.
So it'll be
Yeah.
Oh yeah, sorry, yeah. What is it in Windows to clear screen? CLS, I think. Yeah, okay. Okay, so we did pip install, and then so it's actually right here if this terminal's too small, and then enter. And then now if I try to import it, I'm sorry, it's not. It's going to be I think it's, yeah. Okay, perfect. So that means it's installed. If I can import that, it's fine. So we're gonna leave this terminal here for a second. So there's all kinds of Python IDEs out there, but Python's one of those languages, I think it's easy enough that you don't really need an IDE. You can install like PyCharm or something like that, but let's just use Notepad++ to get us through today. So let's type in Notepad++. And everyone should have it installed, right? I think they installed it on the computers for us. And let's do new. And before we even paste in any code, let's just go ahead and save. Oh, does it not let us do that before we paste the code? Okay, fine. So MQTT Python, we're on this page. Scroll down until you see some Python code right here. So under getting started. Because this would take a long time to type, and I'm not actually going to give you an assignment on this, we can go ahead and just copy this. So we went from here to here, and then go ahead and paste that into Notepad++. And then now we can save it. And let's save it just to the desktop for now. We'll call it messenger.py. The syntax highlighting for Notepad++ Python isn't the greatest, but hopefully everyone here can read it. So what this is remember I told you that there's this thing called a message broker that handles all the message passing. We have this follows the it's called PubSub, not like public sub, but like publish subscribe. And the idea is that somebody's publishing and people are listening and get back a subscription. Now what's nice is that Eclipse, how many people have heard of the Eclipse organization before? They're very associated with like Java, and they have an IDE and stuff like that. Yeah, so they have a server for doing basic testing. Now, when we're publishing and subscribing, we don't want to publish and subscribe everywhere. What we do is we create these things called topics. So for example, I might have a topic called sensors, and any sensor information gets published on there. Or I might even want to get more fine-grained, and rather than have sensors, I might just want to have one called like temperature, and only temperature-related events, either or thermostat maybe, and just thermostat related events. There's different ways to handle this. Okay, but that's what this is right here. This thing is called a topic. Now they've come up with a format. Usually I use human readable names for my topics, but we'll leave this as is. I like to use things like again, like slash sensors and stuff like that. But okay, so we'll go through the code. So this imports the library. We've seen this before. We've got a couple of functions. Usually when you see a function name, it has the word on. Usually that means it's an event. It's event-based. So what happens is it tries to connect to the server, and then when it does, it executes this function right here. Okay? So it's very simple. When it connects, it just says connected, does a print statement, and then it subscribes to that specific topic. So we're a subscriber. Remember I told you we have publishers and subscribers? We're going to subscribe, and anything on this topic called sys, anytime anybody publishes to it, all the subscribers are going to get it. I think we can change it. Let's just change it to IRSC. That way we can test. My worry is that that's in the default documentation, so somebody could be trolling it right now and just spouting all kinds of profanities, and because it's an open server that anybody can use. So I'm pretty sure we can just set our own topic. I doubt anybody's on the IRSC topic. So that's when we connect. We subscribe to that topic. Then every time we get a new message, we have this callback, and all it does is it just prints it. Okay. Now remember what we talked about before. So here we're just making a new instance of the client. There's a class called client. Remember, going back to, we did object-oriented programming for a while. So there's a module called MQTT, and there's a class called client. Okay, so we make a new instance of it. Now this is what's interesting. Remember I told you before that we can, onConnect is a function. OnMessage is a function. And what we're doing here is we're passing a function as an argument. We're saying that every time I get a new message or I connect, call this function. So the idea is that we've written these functions, even though we copied and pasted it, we wrote these functions, we can modify it, but you know what we can't modify? This right here, this MQTT client. We can't modify that, or we shouldn't anyway. And so what's great is when it gets a message, which it may wait 10 or 20 minutes for a message, every time it gets a message, it calls the function that we told it to call. So this is really cool that we can pass around functions as arguments. We don't just have to pass around strings and stuff like that. And then here we actually go ahead and connect. And then this loop forever, this just blocks. This keeps it going forever, okay? So let's go ahead and let's run it. I haven't tested on these computers. This may or may not work, but we'll find out. So you type in Python, and then since we save it on the desktop, we should be able to type in messenger.py. See if it actually connects, or if our firewall is going to keep us from connecting. Firewall might be keeping us from connecting, unfortunately. Unless it's that specific server. So let's see if there's another. Here's one. Okay, 1883. Let's see if this, because it looks like it's not connecting. So let's try this instead. So test.mosquito.org. Let's see if this one's going to work. I'm pretty sure this one actually works. I think I've used this one before. So if we want to stop it, Control C. Ah, perfect. Okay. So let's use that instead. Test.mosquito.org. Okay, did everyone get connected?
No. I'm getting some error when I try to type my speed up a lot.
Oh, Control D. So you have to be on the regular command line. Yeah, type. So you do Python space, hit the escape key. Do Python space messenger.py. Perfect. Okay. So everyone run subscribers to the IRSC topic. Now, I don't know if this demo server, how it works. It's going to be a little bit of an experiment today, but I guess that's what today's for. So right now, this code is a subscriber. I guess messenger was a bad name. It's really a subscriber. That's what we should have called it, but too late. We made a mistake. I made a mistake. It gets messages, but we want one that sends messages. So what I'm going to do is I'm going to, and this time I'll name it correctly. I'm going to make, so I'll just do this. That way we don't have a million messages going through. But I'm going to make one called publisher.py. And this one's going to be a little bit different. I don't really care about getting messages, so I'm going to get rid of this. I'm sorry, so everyone here is a subscriber. I'm not really concerned about subscribing to messages. I just want to be able to send messages. So we go back to the documentation and look for publish. So I think we just use okay. By the way, this is programming in the real world. You don't have everything memorized. You end up looking up a lot of stuff. Okay. So I want to connect. I don't actually care about the onConnect event anymore. No, I do. But I do it down here. Okay. I don't care about callbacks because I'm sending the message. So I connect. And I just call loop start. And then let's go ahead and do client. And then what was our topic name again? IRC. And then whatever data I want to set it. I'm going to keep it simple. I'll just use a string. But here you could actually have JSON if you wanted to. So this should work. If not, I might have to change some things, but we got a little bit of time here, so let me go ahead and run. Okay, did everyone get a message? Did it say hello or something like that? Nope, didn't go through. Publish example. Hopefully Steve can give us a good example. Okay, so we've got our client. We don't really care. Connect. I think we don't call the loop start. So we created our client. We connect, and then I think we just publish. I think that's it. We can have an on publish if we want, just to let us know that it was successful. I'm not going to bother. Let's just see if this runs. You can see here, this is an IoT example. So house bulb 1, set it to on. Get messages? Perfect. Okay, so that was it. It was just the order. So the idea is that I'm here as a sensor. I know nothing about your computers. All I know is test.mosquito.org. I know how to send to a broker. And then the idea is that everyone here is a listener. Well, think about this. Imagine if you've got a real-time system. So we talked about web services with Twitter, but what's with Twitter, I might be getting huge streams of data. So I talked about the IoT case, but imagine if you're trying to get information like a real-time stream from Twitter. Something like a message broker actually might be super useful because you're constantly connected and then every time a new tweet comes through, you can call your on I don't remember what to call it. It was like on subscriber on message or something like that, and have it call callback. Okay. So anyway, so most of that was just to get Anaconda installed. That's the important part, but this is kind of interesting because it's like in the real world we use these messaging patterns. The reason we use them is to decouple, but you know, it's not uncommon. Like for example, I during my dissertation I used this very large system that was written in Java, and the system was just like this giant monolith that I did not want to modify because it was overly complicated. I just had one thing I needed to do with it. And so what I did is I wrapped it around a message broker, one called 0MQ, and then I had my own code, and then I would just have it send the results over 0MQ, and then it decoupled the systems. So I didn't have to know about any of the internals of that system. I would just send messages back as needed. So, okay, but you're not going to get an assignment on that. That's kind of advanced, but I guess you could write like a chat system with that, right? That'd probably be the easiest thing everyone in here could write. Just a simple chat system where you're both a publisher and a subscriber. So you can publish to everybody if you have something to say, but anytime somebody says something, you want to see what everyone says. Okay. So no new assignment today, but what I'm thinking, I'm leaning toward is because some people are falling behind on the assignments, I'm just going to have you for your final assignment do something simple like install Anaconda and then install a few modules and test them or something like that. Nothing that actually requires any coding. It's just going to be like a little bit of a boost to you, okay? So let's, any questions about any of this? I know we went over a lot of random topics today, but, and again, I wouldn't expect you to know all of this. This is more like the starting point. Like, oh, you know, message brokers, that was something interesting. Then you kind of go down the Wikipedia rabbit hole where you start learning about message brokers and messaging patterns and publish, subscribe, and all that stuff, okay? So that's it for today. If there's no questions, for those of you that already finished the assignment, you can head out a little bit early. But everyone else who still needs help, just hang out for the last 20 minutes and I'll go ahead and give you individual help, okay? Any questions? Okay, so we'll separate now for those that are done. I'll see you on Monday. For everyone else,